Good morning, students. In this section, we will discuss about Wheatstone Bridge. Mainly, this Wheatstone Bridge is used to measure the unknown value of resistance. Unknown value of resistance. This is the purpose of this Wheatstone Bridge. This Wheatstone Bridge will be measure a resistance value of greater than 1 ohm. That means greater than one ohm of resistance can be found by using this Wheatstone bridge. Now we will see the existence of Wheatstone bridge. Simply here we're having Wheatstone bridge like this. It is the first arm, it is the second arm, third arm, fourth arm. These are the four arms, and I am naming these arms as A, B, C, D. And between the terminals A and B, we're having one switch and as well as DC source. DC source we're having between the terminals A and B. And between the terminals C and D, we're having one galvanometer G. G is the galvanometer. Now I'm representing the arms like it is R1, it is the first arm. So in the first arm we're having a resistance R1, and it is the second arm R2, it is the third arm R3, it is the fourth arm R4. And I'm representing this one as E, supply E, and it is switch. Yes. And the current flowing to the first arm I'm representing as I1, and from the second arm it is I2, from the third arm it is I3, from the fourth arm it is I4. These are the currents flows through the different arms. Now the construction point of view, we can say here like between the terminals A and C we're having resistance R1, between the terminals A and D we're having resistance R2, between the terminals C and B we're having resistance R3, between the terminals B and D, we're having the resistance R4. And between the terminals A and B, we're having a switch and a source, DC source E. I1, I2, I3, I4 are the current flows through the resistances R1, R2, R3, R4 respectively. And between the terminals C and D, we're having a galvanometer G. Now, coming to the operation point of view. Now, look at here. Here, these are the two branches. Those two are in parallel. These two branches are in parallel. So, voltage at this branch is equal to voltage. That means in case of parallel, voltage is constant. Voltage is constant. That means voltage at this branch is equal to voltage at this branch. So, in the first branch, I am assuming voltage as a V1 is the voltage in the first branch, equal to V2 is the voltage at the second arm. So according to Ohm's law, we have V equal to IR. So V1 can be written as I1 R1. Here I1 R1 is equal to V2 can be written as I2 R2. I2 R2. Let it equation number 1. Equation number 1. That is. And now here the bridge is in balanced condition. Bridge is in balanced condition. Balanced condition means there is no current flows through the galvanometer. That means from this point to this point there is no current flows. No current flows through the galvanometer. In this balanced state, in this balanced state, I1 will be directly enters to this and continues as I3. I1 equal to I3. It will become I1 equal to I3. So I'm writing here as I1 is equal to I3 equal to. Then here the value of I1 equal to I3 equal to is nothing but E by applied voltage is E here by total resistance. Here is the resistance, here is the resistance, that is R1 plus R3 in balanced condition point of view. Similarly, I2 equal to I4 equal to E by R2 plus R4. Substitute these two values, that is I1 value here, I2 value here in equation 1. That is substitute these values in equation 1. So by substituting there, we will get, instead of I1, this is the value you have to substitute, that is E by R1 plus R3 into R1 is here, into R1 equal to I2 is nothing but this value, E by R2 plus R4 into R2 is here, into R2. Here is the E value, here is the E value, get cancelled. Now do cross multiplication. Then this R1 into this one, R1 into R2 plus R4 equal to this R2 into R1 plus R3. Just multiply internally. So R1 into R2 plus R1 into R4 equal to R2 into R1 plus R2 into R3. Here R1 R2, here R1 R2 will get cancelled. And finally you're getting here R1 R4 is equal to R2 R3. It is called as, it is called as bridge balancing condition. Bridge balancing condition. Very important point, bridge balancing condition. And if one of the resistor is unknown, that means I'm assuming here R4 is the unknown. Assume R4 is unknown, unknown value. That is, I'm assuming as Rx is equal to R4, unknown value. So by substituting this value here, R1 Rx is equal to R2 R3. Now I'm letting this one to this side. So Rx is equal to R2 R3 by R1. It is the unknown value of resistance. Like this, we can find the unknown value of resistance by using Wheatstone bridge.